All right, we are going to continue talking about similar right triangles. Today we will bring back the idea of a geometric mean. Rodney?
Can I borrow a pencil?
Sure.
Are your pencils in the front of the classroom?
They are in the brown bucket on top of the white shelf by the brick pillar. So if we are trying to find the geometric mean between 6 and 24, we should be able to do that by setting up a proportion. What is that proportion?
6 over x equals x over 24.
Good. The geometric mean means we set up a proportion, and where the means are, we put our variable. That is the geometric mean. Remember, these ones are called the mean. The other two, 6 and 24, would be called the extremes. Okay, to solve this, we cross multiply x times x. 6 times 24. To solve this, we would square root, and x equals 12. Questions, concerns? Need more time with the warm-up or with the objective? Alrighty then, we'll jump on in. There are two tricks, we call them, to find the missing values when an altitude, we talked about those yesterday, when an altitude is dropped from a right angle in a right triangle. So these diagrams are going to look just like they did yesterday, where we've got one big right triangle split into two smaller, similar right triangles. But this time we are going to talk about a couple tricks that we know instead of having to identify all the similar triangles and think about which sides would match up with each other. Anybody needing more time? Okay. The first trick, in my opinion, is the easier one to remember, the heartbeat trick. The actual theorem states that the altitude is the geometric mean of the lengths of the two segments, meaning the two segments of the hypotenuse for the giant triangle. You only use this when you know or are looking for the altitude. So we only use this heartbeat trick when we either know the altitude or we're looking for the altitude. The altitude has to be involved some way, somehow. It's called the heartbeat trick because it kind of looks like a heart rate monitor would look on the screen. So the picture that goes with these is that we jump up, jump back down, and flatline out again. So when we set this proportion up, we started over here by the 6. So 6 comes first. We went up to the x and then came back down from the x. So x goes on bottom and then on top. And we flatlined back out by the 3. Well, that's what the actual theorem states. The altitude is the geometric mean of the two lengths. So the altitude this time is x. We put that in as the geometric mean between the two lengths. If you prefer to just remember the actual theorem, that's fine. Some people like to have the little heartbeat trick. So they just draw their little heartbeat bloop. But we still need to solve this. So to solve it for x, what would we do? Cross multiply. X squared equals 18. Square rooted. The directions didn't say, so if you give me a decimal, that's fine. What would you get? 4 point what? 4.4? You're going to have to speak a little louder. Okay. Or if you give me the simplified radical, for me that's even better. It would be 3 root 2. I would accept either answer. Okay, so let's move on to example 2. If, again, we're using this little heartbeat trick, who can tell me what my proportion would look like? Majay?
16 over 12 equals 12 over 8.
Good. Make sure you're using the altitude as the geometric mean, even if it's not what you're looking for. So this time when we cross multiply, what do we get?
16x equals 140.
Good. And when we solve, what do we get for x?
X equals 9.
Good. Questions about our first trick? Anybody need more time on this slide? All right. The second trick, some people call it the alligator. I've also heard it called the boomerang, which I prefer. This one is, in my opinion, a little bit trickier to remember the trick. And I personally was never taught it as a trick. I just had to memorize the theorem. The length of each leg is the geometric mean of the hypotenuse and the segment of the hypotenuse closest to the leg. The way the boomerang trick goes is that you start down here at the portion of the leg closest to, or the portion of the hypotenuse closest to the leg you're working with. You go up along that leg, and then you come back out around down the whole hypotenuse. So that's why it's supposed to, some people call it a boomerang trick, some people call it an alligator mouth. Okay, so we started at the length of part of the hypotenuse, which was 3, over, then we went up along the leg we're looking for, in this case, x. We had to travel back down that leg, x. And then we went the whole length of the hypotenuse, which would be 5. Okay, the tricky part in the theorem is that when they refer to the leg, they mean of the biggest triangle. Of the big triangle, not just a leg of one of the little triangles. Again, we cross multiply, so we take x times x. Anybody? X squared. We also take 3 times 5. We would square root it. I'm fine if you leave it as the square root of 15. That is a simplified radical. If you really want a decimal approximation, what would it be? Close to 4, 3 point something? 3 point what? 8.7. Questions, concerns? Yes. The length of the whole hypotenuse. So 2 plus 3. Any other questions? Ready to go on? Yeah. Okay. On example 4, we are asked to find x, y, and z. Now, in my opinion on this one, it's going to be easiest to find x first. In order to find z, we actually need both x and y based on the heartbeat trick. So we definitely can't start with z. We don't know the length of the leg near y, so that makes it tricky unless we were to use Pythagorean theorem to find it. So I would say start with x. And on this one, we would be using the boomerang method, so to speak. If it helps you to draw the little boomerang picture, you can. You don't necessarily have to. So, who thinks they know what would go in that proportion? Yes, ma'am. X over 14 equals what? Close. John? 14 over 16. So in this case, we started at the X, we shot our boomerang up along the 14, and then it had to come back across the 14. That's why the 14 gets used twice. And then it went all the way along the hypotenuse of 16. Okay, so we cross multiply and solve. What do we get on 96? X equals 12.25. I would not round that in this case. First of all, it's not a terribly long decimal, so we can just leave it. Also, we still need to use that number to find other lengths. So if we round this one, then our other ones will also be slightly off. The easy one to find at this point would be what? Y. Is Y easy?
Because you just subtract 12.25 from 16.
Good. In order to find Y, all we need to do is subtract. We know the whole hypotenuse. We just found a piece of it. So Y is going to be 16 minus 12.25, which is 3.75. So now we found X. We found Y. We just need to find Z, which Z we find using that heartbeat trick because it is an altitude. So who can tell me the proportion I would set up there?
12.25 over Z equals 0 over 3.75.
Okay. 12.25 over Z equals Z over 3.75. Now this one will get a little ugly. Z squared would equal what?
45.9375.
9375. Might as well just leave the whole thing, and then you can round when you square root it. Square root both sides. What do we get for Z approximately? 6.7?
Rounded it would be 6.8.
Rounded 6.8. Okay. Questions? Concerns? What was it unrounded?
6.777.
Oh, okay. Yeah, we'll just leave it there. That's fine. Questions about example 4? Either of our tricks. Again, if you prefer to just memorize the theorems, that's no big deal. If it helps you to make your little sketches along it to set up your proportions, that's fine. All right, for the rest of our examples, we're just solving for any variables that they give us. On example 5, if we are referring to the tricks, would we use the heartbeat or the boomerang? Boomerang. Can somebody new volunteer to tell me the proportion they set up? Atea?
3 over y equals -1.
Very good. We can cross multiply and square root. Okay, this would be a simplified radical of 3 root 3. Did anybody get the decimal instead? 5.19? Okay. Make sure you follow whatever the directions say. So, for example, if on a quiz I tell you I want the simplified radical, then I will not take the decimal. Some people lost a point or two on that last quiz because the directions said simplified radical, but I was given a decimal. If the directions don't say, then I'll accept either way. But if the directions tell you specifically what to do, you need to follow them. Questions about that? Okay. Next one. Solving for K. Are we using the heartbeat or the boomerang? Boomerang. Ari, what proportion did you set up? Very good. Okay, k squared equals 20. When we square root, k would equal 2 root 5, or approximately what? 3.5? 4.47? So we'll just round it, 4.5. Do we agree? Is that okay? Not okay?
That's okay.
Okay. All right. Moving on. On example 7, are we using heartbeat or boomerang? Heartbeat this time. We have the altitude. So if the altitude is involved, you should be using the heartbeat trick. Somebody new want to tell me their proportion? Akira? A plus 5 over 12 equals 12 over 18. I would agree. The altitude is what gets used twice. On this problem, when you cross multiply, what do you have to remember to do? Distribute. Remember the 18 will get multiplied by the whole thing, a plus 5. Okay, so distribute 18a plus 90 equals 144. Subtract 90, we get 18a equals, and then we divide by 18. A equals 3. Bless you. Questions, concerns about example 7? Need more time with it? Okay. Last one involves 3 variables. Which one do you want to find first? Okay, and if we're finding x, which method do you want to use? Okay. We could find, oh, that's not what I wanted. We could find x using the heartbeat method. Somebody new, give me the proportion there. Caleb?
16 over 12 equals 12 over x.
Okay, that would work. 16 over 12 equals 12 over x. Cross multiply and solve. 16x equals 144. X equals 9. I think we've seen that one already. Did we have to do that to find x? No. How else could we have found x? Okay, we could have just subtracted. I'm fine with that. Either way you did it, you should have gotten 9. Okay, if you see an easier path, you can take it. If you didn't see it and you set up the proportion, that's fine. All right. What do we want to find next? Okay, it doesn't really matter at this point. You could find y or z next. Let's just follow our alphabet and go with y. If I'm trying to find y, which trick would I use? Boomerang method. Can anybody give me that proportion? 9 over y equals y over 25. Sounds good. Cross multiply. Y squared would equal 225. When we square root it, we get y equals 15. Do I have to use the boomerang method to find z? What else could I use to find z? We could use the Pythagorean theorem now to find z. Okay, we have 2 sides of a right triangle. We're just looking for the third side. Would you rather use Pythagorean theorem or would you rather use another boomerang? Here in a a mixed response. Pythagorean theorem was the one I heard most clearly, so let's go ahead and review it. Doesn't hurt. We got a test coming up anyway. What am I plugging in for A? 15 squared. For B? Z squared. And then for C? 25 squared. Okay, 15 squared plus Z squared. 25 squared. 625. When we subtract, Z squared equals 400. And when we square root, we get Z equals 20. Now, if you had done that using another boomerang, you should have gotten the same thing. Either way would be fine. What questions do we have about example 8? Nothing? Okay. Your homework, which should also be on your assignment guide, is up on the board.